So the DAC, we can actually output an ADC sort of voltage of our own, like a digital to analog conversion. So if we want, for example, the PIC to specifically output 2.5 volts, then we can do so. And that can be, for example, used to offset some op amp or whatever need be. So what you do with the DAC, it's quite simple actually. You just go to your init, wherever you initialize everything, make sure you bank switch correctly, and so all the variables play nice together, and you actually can alter the special function register values. So what the PIC runs on a 5-bit DAC. So we go to the data sheet, go to the digital to analog converter module, and you can see it's whatever out, it's just basically Vsource plus minus Vsource minus, which is basically 5 volt minus 0. It is the reference voltage of the PIC. And here the important parts are happening. So we can see VREFCON1 controls the DAC. So the DAC, so the first bit is enabling the DAC itself. 6th bit is the positive reference voltage, and that is the normal reference voltage of the PIC. It is, so we want this one, and then we can also, and this is actually enabling the output of the DAC on the thing. So the rest aren't really as important because VDD by default is 00, and the VSS is by default selected by this register. So if we can just make these zeros and all 3 of these ones. So that is effectively what we're going to do to set up the DAC. So move literal to working, this little binary value, move working, the file vrefcon1. So we just make all the top 3 bits 0 as per this data sheet, and the rest we can just keep as 0. So 0, 0, 0, 0, 0. And that should about do it. And to actually output the DAC, we then specifically set an output value for the DAC. So we can just go to this little register right here, and the bottom 5 bits are what we actually wanted to output. So whatever voltage you wanted to output, you just do that in binary, obviously with the steps. So it is limited to 34. So it's basically on a scale from 1 to 32, from 0 to 5 volts, what do you want to output? So this is the step for the voltage you want to output. So let's say you want to output 16. So it's 16 times this if you load 16 into that register. So let's say we want to output 16, move a little to working 16. So 16 in binary is effectively this. So no, it's this. And so if you move that, and then you just simply move that into VREFCON2, and you should be able to read some specific voltage on that specific pin when you load that value. So it's pretty straightforward. Just do the setup here, just a single register setup, and then just load whatever you want it to output into VREFCON2, and that is the DAC.